The film you are about to see was made in 1961 and shows some of the day-to-day operations within the Albion factory at that time. This film had never been edited or used and was discovered in 2017. The factory was built in Scotstoun in the west of Glasgow, close to the River Clyde. This aerial view looks south over the factory and shows the Clyde and the King George V dock. The factory faced onto South Street, and the office block and the two four-storey concrete blocks were erected here by the year 1914. Seen between Albion and the Clyde is the very tall factory of Harland and Wolff, which was acquired by Albion in 1969 to become the new axle factory. This view shows approaching the factory down Balmoral Street. After the railway bridge, the East Building machine shop and the gear shop are situated on the right, and the experimental department and the tool room are situated on the left. Historically, Albion had designed and made all its major components. By 1961, Albion produced rear axles for its own vehicles and some Leyland and Scammell vehicles. At this time, around 250 rear axles per week were being produced. Here we see part of the axle body machining area, which was laid out as 3 machining lines. Axle machining operated on both day shift and night shift. Axle bodies were moved through machining operations on an overhead rail system to minimise handling. The axle body itself was a bought-in welded assembly of steel pressings. Here we see an axle body having holes drilled and tapped. Note the jigs and fixtures in use, together with the lifting equipment, all designed and made within Albion. Here we see a grinding machine with an axle body mounted between centres. The diameters being ground are for the hub bearings. Note the large abrasive wheel rotating at high speed and the use of coolant. Albion also used a more complex grinding process known as centreless grinding. On 3-axled reever trucks, a drive shaft passed through the middle axle to the rear axle. This scene shows a horizontal boring machine machining the bearing housings for this shaft. Many components used by Albion underwent heat treatment. Heat treatment of steel involves raising its temperature up to approximately 900 degrees centigrade, depending on the actual process, the intention being to improve the properties and crystal structure of the metal. Processes would usually be normalizing incoming parts before machining and hardening parts after machining. Here we see rear axle half shafts being quenched in oil after hardening. Some distortion could occur, therefore following hardening the shafts would be inspected and straightened if required. After machining and washing, the axle bodies would be passed to the rear axle assembly line. Here we see the first operation of assembly, that being fitting the oil drain and level plugs and the studs for the driving head. In 1961, Albion opened a new gear shop for production of the GB241 range of gearboxes. This was laid out with production lines for both machining and assembly. After machining, the gearbox components were temporarily stored, and from there, kits of parts for each gearbox were placed in wire baskets and fed to the assembly line via a large industrial washing machine. Albion assembled approximately 240 gearboxes each week on a day shift only assembly line. The standard gearbox was a 6-speed constant mesh unit. Here we see gearboxes moving along the assembly line. And here we see the gear selector assembly being fitted. This sequence shows the 6-speed gear being fitted to the back of the gearbox. Note the extensive use of air-powered tools to assist assembly. The final operation on the assembly line was testing the gearbox. Oil was added and an electric motor fitted to the clutch housing. Each gear was then tested for smooth selection and quiet running. Both Leyland and Albion had their own transport fleets, and this sequence shows a Leyland fleet vehicle being loaded with completed Albion gearboxes for delivery to Leyland plants in England. Here we see the engine assembly shop. In 1961, Albion were machining and assembling the EN335 4-cylinder diesel engine and the EO900 6-cylinder diesel engine. EN335 engines were assembled on an assembly line. EO900 engines were assembled in a static assembly fixture. The 900 engines were intended for railcar use, and the EN335 engine was fitted to some Albion Chieftain models. Albion used a vast range of metal components. To ensure the components possessed the properties to be reliable in service, Albion had a laboratory staffed by metallurgists. Their first consideration would have been the metal used to make the component. Also, the components had to possess properties that allowed the most economical manufacturing process to be used. Metallurgists would test components for tensile strength, elasticity, ductility, hardness, toughness, and brittleness, and thereby ensured quality control of Albion's heat treatment department. Before you can manufacture, you have to design and prepare detailed drawings, and Albion always had its own engineering design department. The four-cylinder EN335 diesel engine, the GB241 gearbox, and the hub reduction axle had all been designed at Albion. The recently introduced LED cab had also been partly designed by Albion. In addition to these, since 1953, Albion had responsibility for the design of Leyland's 15-litre EO900 diesel engine. Here we see the frame shop where side members, cross members and suspension were all bolted together to form the chassis. Note the use of fitted bolts, not rivets. Albion always used bolts. Chassis assembly comprised assembling the basic vehicle, painting the vehicle, then fitting the electrics, and then the cab. Here we see the frame being dropped onto the axles, after which it was lifted over for the fitting of the engine and gearbox unit. The engine seen here being fitted is the Leyland 400 six-cylinder diesel engine. When this had been completed, the vehicle moved forward and the braking system, fuel tank and pipework, radiator and pipes, and steering were all fitted. The vehicles moved forward as assembly progressed until they reached the paint shop. Here we see a chassis entering the paint booths. Tyres, hoses and engines were masked and 2 coats of spray paint were applied, one undercoat in brown and one top coat in silver. The paint was touch dry in approximately 10 to 15 minutes. On exiting the paint booths, vehicles were inspected and the electrical wiring and tail lights were fitted. The vehicle cab shown here, known as the LAD cab, was made by Motor Panels in Coventry and arrived at Scotstoun as a bare cab. Electrical wiring, lighting and instruments were fitted and tested, and the cab then moved to the post-paint area ready for fitting. At the time of filming, output of assembled vehicles was approximately 90 per week, working day shift only. After assembly, vehicles were moved to the finishing off department at the Yoker factory, where any special parts were fitted, final inspection and tests were carried out, and the vehicles prepared for dispatch. The vehicles seen here are leaving the Yoker factory. The experimental department tested new designs before introduction and also carried out continuous testing of current trucks to assess reliability. Here we see a Chieftain truck loaded with 6 tons of test weights on a test run over poor road surfaces. As part of vehicle testing, once a year a team from Albion took trucks to the Motor Industry Research Association premises to make use of the specialist test facilities available there for manufacturers.